Hi, in this video we are going to see about a Python IEEE project which is entitled as Deep Learning Based Blood Group Detection Using Fingerprint, which is an enhancement of IEEE base paper title Artificial Intelligence and Image Processing Techniques for Blood Group Prediction, which is an IEEE 2024 conference paper. So before seeing the execution of the project, let me brief about this project. So we all know about blood is very important for every human being, and everyone should know about their blood group, because in medical emergency, if the blood group is not known, they could not able to make the treatment early. So everyone will be knowing about their blood group. So in traditional method, the blood group is being identified by collecting the blood samples, and then they will be testing it in a laboratory by mixing up with some reagents, and then they'll be finding out the blood group. But we all know that artificial intelligence is growing every day, and especially in the healthcare domain. So in this paper, the authors have introduced the artificial intelligence deep learning image processing technique for the blood group prediction. Kindly note that we are not going to implement the same as mentioned in the base paper. So now let me say you what is done in the base paper, and then let me explain what we have implemented in the proposed system and enhancing the base paper. So in the base paper, the authors have used MATLAB simulation for detecting the blood group, and they have used blood sample images for identifying the blood group. So here you can see the screenshot of the thing that they have implemented using MATLAB. So they are giving the blood sample images, and the image processing techniques is being applied, like red color panel, green color panel, and then threshold value, morphology kind of things is being applied, and finally they are identifying the blood group. So this is about the base paper concept. So now let us see about our proposed system and what we have improved from the base paper, that is existing system. So in the proposed system, we are going to implement two different modes. One is using the blood sample images, that is as mentioned in the base paper. Another one enhancing the system using the fingerprint images. So both the modes, we are going to use two models, separate models, but we are going to use the same model. The model is MobileNet v2 architecture. So first let me tell you about the using the blood images. So here we are going to use MobileNet v2 architecture. The training accuracy that we have achieved is 100%, and validation accuracy that we have achieved is 100%. And coming to the fingerprint based image, that is our proposed system, here we are going to use MobileNet v2 architecture, and training accuracy that we have achieved is 94%, and validation accuracy we have achieved is 90%. So now let us see about the proposed system. So I'll tell you the difference. So difference is, in the existing system they have used MATLAB. In the proposed system we are going to use Python machine learning deep learning concept, and in the existing system they have used only the blood sample images, but we are going to use both the blood sample images, and also we are going to enhance the system by using fingerprint. So based on the fingerprint, it is going to predict the blood group, and also we have used more data set images than the existing system, and also we have improved the accuracy for both the modes. So we are going to implement using two different modes, and we are going to use MobileNet v2 architecture. So these are the difference between the existing and the proposed system. Though these things are we are going to implement in the proposed system. So this is the proposed system title, that is deep learning based blood group detection using fingerprint, and the IEEE base paper title is Artificial Intelligence and Image Processing Techniques for the Blood Group Prediction. This is the IEEE base paper abstract. And in our proposed abstract, so as mentioned, the blood group detection is the very important procedure in the medical diagnosis, particularly for the transfusion medicine, emergency healthcare, and personalized treatment plans, because without knowing the blood group they cannot able to do any kind of treatment. So in the existing system, the traditional is a laboratory based testing system, so that is a time consuming. So to overcome that, we are going to implement this artificial intelligence based, deep learning based blood group prediction system. So here we are going to use two different modes, whichever I mentioned, that is blood images and the fingerprint. So we are going to use Python for the backend processing, and for the web framework we have used Flask, so which contains the front end part with HTML, CSS and the JavaScript for the efficient blood group detection. So in the first mode, that is using blood images, so here you are going to use mobile net architecture. So here, coming to the data set, the first mode contains 750 blood images, so where 500 for the training and the 250 for the testing purpose. And here we have achieved training accuracy of 100% for both the testing and training. And coming to the second mode, that is our fingerprint based prediction, you are going to use mobile net. Here you can see that for the data set part, we are going to use 10,477 fingerprint images, where it contains 6,000 images for the training set and 4,477 for the testing purpose. So we are going to use a large data set images, and the training accuracy is 94 and validation accuracy 90%. So based on this, we are going to do, so those things are being summarized in the proposed abstract part. This is the proposed abstract. So moving to the, before moving to the existing system, I'll show you about the data set part. So as mentioned, we will be having the two models, blood group based detection. Blood data set contains test and train. So here you can see the train contains, so here both will be having 8 classes of the blood groups, that is A negative, A positive, AB negative, AB positive, B negative, B positive, O negative and O positive. So let me show you the data set images. You can see this is a sample blood images data set image. So you can see these kinds of images are available in the training and test part. So as mentioned, the first mode, that is that contains around 750 images, that is 500 for the training and 250 for the testing. So here you can see this is all the A negative, this is for these all the images for the A positive, and this is for AB negative, this is AB positive, B negative, these are all for the B positive, these are all for O negative, and these are all for O positive. Similarly, the next model, that is our fingerprint based model, contains test and train. So here we have large set of data set, which is around 10,477. So here in the train you can see that for the A negative we are having 1,009 images. Let me show you a few images from it. So these are all the sample images from the data set part that we are going to train up the system. So here you can see this contains 1,009. This is A negative, and for A positive 565, and similarly for AB negative, these are the images of the fingerprint based, and this is for AB positive, this is for B negative imaged fingerprint, and B positive fingerprint, and O negative fingerprint, and O positive fingerprint images. So this is for the train, and similarly we have for the test cases also. So this is about the data set part images. So coming to the existing system, so here in the existing system we are going to take the base paper as existing system. So as mentioned in the base paper, they have done using MATLAB, and they have used blood sample images, and those details have been described in this existing system part. And disadvantage of the existing system, so they have used MATLAB, and the limited scope of reduction is there, and the hardware and the resource dependency is there for the existing system, and it wants a manual preparation, image capturing kinds of thing. And here they are going to use only the blood images based thing. They're not going to use fingerprint based, they have already done with it, and there is a lesser accuracy and scalability issues kinds of thing. So those details have been described detailed in this existing system part, disadvantages of the existing system part. And coming to the proposed system, as mentioned, so we are going to use the Python, HTML, CSS, JavaScript for the front-end part, and being connected using the Flask web framework, and we'll be having two different modes, and here we are described about the data set part, and we have used and described about the fingerprint images dataset part and the model that you are going to use and what is the accuracy that we are given. So two different modes that we are going to use, and everything is being described detailedly in this proposed system. And coming to the advantages of the proposed system, as mentioned, so we are going to use Python and we are going to use two different modes. Especially we are going to use fingerprint based detection, and we are having high accuracy and efficiency, and it is real-time and automated detection, and we have good scalability and accessibility, and we have resource efficiency, so there is no need of any hardware kind of thing. So and we are having good accuracy, and we are having dual mode, and we have enhanced user experience, reduced human intervention. So these are the advantages of the proposed system and compared to the existing one. Those it is are being described in the advantages of the proposed system. And coming to the system architecture, you can see we are going to use two data sets. One is the bled images data set, and another one is fingerprint images data. So that is going to be given as an input. Pre-processing feature selection will be made, and mobile net architecture. So it will be having two different models, but we are going to use the same mobile net architecture for the two different models. And here the first one contains the bled image based blended group detection and fingerprint based bled group detection, second one, and it is going to predict the result as the bled group as A negative or A positive, AB negative or AB positive or B negative or B positive or O negative or O positive. And finally we'll be showing the performance analysis of each model and the graph part of it. And coming to the hardware requirements, so here you can see the system requirements of it. And coming to the software requirements, so this project can be executed in Windows 10 or 11. The coding language used is Python 3.12.0. Web framework is Flask, and front-end part can HTML, CSS and JavaScript. So this is the IEEE base paper reference. So now let us see the execution of the project. So before execution, make sure that you have fulfilled the requirement that is mentioned in the requirements file with the exact version of the Python the library is installed in your system. So now inside the source code folder, just in the address bar type cmd and click enter. So the command prompt window open with the exact location of it. Now type python app.py and click enter, and kindly wait for a few minutes. So now copy this URL. Just go to any of your browser. I'm going to Google Chrome and paste the URL that we have copied and click enter. So now you can see the home screen or welcome screen of the project with the project title deep learning based bled group detection using fingerprint. So first click this login menu. It will be navigated to the login page. Kindly note that this is a static login page because we have not used any database in the project. So just enter the default username and password as admin and click the login button. So now you can see the login success message and click OK. So now it will be navigated to the preview part where you need to upload the first mode, that is bled sample images. So now let me select this choose file. So now go to the project source code location. Inside that we have the test data set. We have the first folder that is bled group detection. So here the test data, you can see the different folders. You can select any one and you can find the what is that bled group. So now let me show you for the first case. Let me select any of the image here, and you can preview the image here and then click submit. So now you can see the predicted result. So here you can see the image that we have selected, and you can see the bled group predicted is A negative. So once if you wanted to check with the other case, so let me click the preview menu again. So the preview will be loaded. So let me select the other case now from the test data. So you can check with any other case that is given in the test or both in the train or test also. So now you can see the predicted bled group is A positive. So this is the image bled sample image that I have selected. Now let me select the preview menu again, and now let me check with the other case for you and then click submit. So now you can see the image that I have selected and the predicted result is AB negative. And let me show you with the other case now, and let me select an image from here and then click submit. So now you can see the predicted bled group is AB positive. So now let me go to the preview menu again. I'll just select an image from randomly and just click submit. And now you can see the predicted group is B negative. So now let me go to the preview menu again. I'll just select a image randomly from it and then click submit. So this prediction result shows the blood group is B positive. So now let me go to the preview menu. Now let me go to this case and just select an image randomly and click submit. So now you can see the predicted blood group is O negative. And finally I'll just select an image from this case and then click submit. So now you can preview the image that I selected, and the final case is predicted as blood group O positive. So now whatever the cases I have shown selected, everything has predicted correctly. So now finally I'll just show you other case. So now I'll just select till now I have shown from the test data. So you can also select from the train data folder. So inside the model we have the data set. So inside that I'm just going to the train part some randomly. So there are lots of images. I'll just select something randomly and click submit. So now you can see it has predicted exactly as the blood group is B negative. So in this way you can check with the all other cases that is available in the test or train. So now let me move to the performance analysis part. So just click this performance analysis part. So here you can see the performance analysis for this MobileNet v2 architecture for the blood sample images. Okay, so here you can see the performance analysis parameter accuracy 100%, precision 100%, recall 100%, F measure value 100%. And here you can see the confusion matrix for all the 8 cases, that is A negative, A positive, AB negative, AB positive, B negative, B positive, O negative, O positive for the true and predicted label of it. So this is the performance analysis part for the first mode, that is using the blood sample images. And coming to the chart part, here you can see 2 different charts. Both the charts are static chart. This is not dynamic chart. As mentioned earlier, we are not going to use any database in the project. So this static visualization chart contains model accuracy chart and the data visualization chart. So first chart is the model accuracy chart, which shows the compares the train accuracy and the test accuracy. So both are 100% of for this MobileNet v2 model accuracy result. So that has been depicted in this static visualization chart part. And second, that chart contains the data set visualization chart, which contains the how many percentage of the images that we have used in the data set. So here you can see A positive contain 15% of A positive images data set, and A negative with 10% and AB positive as 15%, AB negative as 15%, B positive as 15%, B negative as 10%, O positive as 10%, O negative as 10%. So this chart shows the total representation of the images that we have used in the data set part of the 8 classes. So till now we have seen about the first mode. Now coming to our proposed system model, that is using fingerprint based blood group model. So once if you click this, it will be showing this preview image. So here you need to select this other test case part, that is using the fingerprint. So in the test data you can just go into the test data. Here you can see fingerprint based blood group here in the test data. Now let me show you with these cases. So now let me select any of the image from the first class and then click submit. So now you can preview the image that we have selected, and here you can see the predicted blood group is A negative. So once if you wanted to check with other case, just click this fingerprint based blood group. So again the preview part will be selected. So now let me go to the other folder and select an image and then click submit. So now you can see the predicted blood group is A positive for this fingerprint that we have uploaded. Now let me check with other case. So now let me go into this, let me select some image and then click submit. So this predicted result blood group is AB negative. So now let me go to the preview part again. Now let me check with the other case and then click submit. So now you can see the predicted blood group is AB positive. So now let me select the choose file again, and let me select some other image from the other case and then click submit. So now you can see the predicted result is B negative. So now let me go to the preview menu again. Now let me select a case in any of the sample image and then click submit. So now you can see the predicted result is B positive. So now let me go to the preview menu again. I'll just select a case from this part and then click submit. So now you can see the predicted result is O negative. So finally I'll show you with the final case and select an image and then click submit. So now you can see the predicted result is O positive. So whatever the test cases that I have selected, everything has shown perfectly. So now finally I'll just select some other image from the train data part. So let me go into the model folder. Inside that we have the fingerprint. So here in the train part I'll just select some image randomly. So there are lots of images. As mentioned, this dataset contains more images. Let me select this and then you can see it has predicted exactly as B positive. So in this way you can check with the other images that is available in the test and try. So kindly note that important thing. So here the model for both the blood images and the fingerprint, so it is being trained up only with the images that is available in the data set part, whichever I ensured. So it is not trained with other images. So for example, if you are giving some other picture that is an animal picture or a bus or vehicle kind of thing, so it cannot recognize that. So because we are not trained up the model, in case if you are going to train up, it is going to a very big model, so we are not done that one. So here it will be showing some, if you wanted to give only with the images that is related to this fingerprint or the blood samples. In case if you are giving some other images, it will be showing some random result only. So the model does not know about the other images, so it will be knowing about the same images only. So in case if you wanted to give some other images, new images other than the data set, you can give it, but see the dimension that is already available in the test or train folder, and accordingly it must be same fingerprint or the blood sample images. Similarly, if you are giving, it will be identifying as the model that we have trained up with. So now I've shown you the cases with this. So finally I'll just end up with something given like this one, and here it has shown the O positive. So let me go to the next part, that is performance analysis for this fingerprint based blood group. So earlier we have seen for the blood sample images performance analysis parameter, this is for the fingerprint one. So as mentioned, these are two models, both are using mobile and V2 architecture. So here the accuracy is 0.90 and the precision value is 0.98, recall with 0.90 and F measure value with 0.90. And here you can see the confusion matrix for the true and predicted label for all the 8 classes of it. So this part contains the performance analysis parameter for the mobile net V2 architecture for the fingerprint based blood group with these accuracy, precision, recall, F measure and the confusion matrix of it. And finally the chart part. So here it's similarly what we have seen. So this is also a static data visualization chart which contains a model accuracy chart of the mobile net V2 chip for the fingerprint based model. So here you can see the train accuracy is 94% and test accuracy with the 90%. So now let me log out from this part. So this is all about the project deep learning based blood group reduction using fingerprint, and thank you for watching.